Hello, everyone. Welcome to this special webinar on the Southern Plains drought. My name is Joel Lisenby. I'm the Regional Drought Information Coordinator for the Southern Plains region at the National Integrated Drought Information System, or NIDIS. If you're not familiar with NIDIS, you can learn more about us over at drought.gov. You can also sign up for email alerts and even get notified by email when the drought status changes for your zip code. I also sit at the Cooperative Institute for Research in the Environmental Sciences at the University of Colorado in Boulder. In addition to our four presenters today, who I will introduce in just a moment, I would like to acknowledge and thank the following for their role in organizing this webinar. They are Victor Murphy from the National Weather Service Southern Regional Headquarters, Jonna Infanti, Corey Baggett, and Brad Pugh from the National Weather Service's Climate Prediction Center, and Andre Sibbles from the USDA Southern Plains Climate Hub. A big thanks to all of you for your help. Before we get into the presentations, I'd like to first do a few basic housekeeping items. On this webinar, everyone is muted. The webinar is being recorded. The webinar recording will be made available on both the NIDIS YouTube channel and linked to drought.gov/webinars. I plan to send around an email later this week or early next week when the webinar summary has been posted, so you'll all have access to that. We have a very packed agenda today, but we will have a small amount of time for a few questions after each presentation. To ask a question, please use the questions box, which is located within the GoToWebinar control panel, and indicate your name and affiliation with your question. Now I'm honored to be able to present our four presenters for today. It's four regional experts who are going to be talking to us about drought and climate in the Southern Plains. We're going to move from south to north. So we're going to start with John Nielsen-Gammon down in Texas. John is the state climatologist for Texas and the director of the Southern Regional Climate Center. He's based at Texas A&M University in College Station. Next up will be Gary McManus. Gary is the state climatologist for Oklahoma. He's based in Norman. And after Gary, we'll hear from Matt Sittle. Matt serves as the assistant state climatologist for the great state of Kansas. He's based out of Kansas State University in Manhattan. And finally, we'll get some long-range outlooks from Adam Hartman. Adam is a meteorologist in the operational prediction branch at NOAA's Climate Prediction Center. And so with all of that, I'm now going to pass over to John for our first presentation.
Yeah, thank you, Joel. So I'll be focusing on drought conditions in the state of Texas. Next slide shows the short-term conditions in the area. So go ahead and advance one. I find it's really hard to show a map of Texas without including Oklahoma. So apologies for that. You'll hear about Oklahoma later, but you can sneak a peek during my talk as to what's going on up there, because at least along the Red River, it's not very different. The plot on the left shows the 30-day precipitation. So for the past month, there's some white spots on the map, which means places have not seen a drop of rain, extending from the West Texas across the area around San Antonio, and then parts of East Texas are dry also. And the farther east you go, the more unusual it becomes, because rainfall is typically a lot more frequent, a lot more common in East Texas. There's a few wet spots, which I'll mention now and then leave alone, which is a swath across north central Texas, south of Interstate 30 and 20, and also the lower valley around Brownsville and McAllen has been wet, but otherwise we have problems. The plot on the right shows the 90-day percent of normal precipitation, and there are some areas that are extremely dry. Wichita Falls up close to the Red River is record dry for the past few months, with less than a half an inch of precipitation. Dryness extends across most corners of the state on the 90-day time scale. There are only a few areas that are showing up in the greens and blues, which are above normal for that period. And although I don't have a slide for it, I go along with these dry conditions have been unusually warm conditions, especially second half of September and October so far. These have obvious agricultural implications, which we'll talk about later, but we also have long-term drought in parts of the state. The next slide shows our SPI blend drought product from the Southern Regional Climate Center website on the 36-month time scale. So this is when you're starting to affect reservoirs and aquifers and so forth. And there's three hot spots that show up here. We've got West Texas again. Part of that is poor radar coverage, but I know from data out there that it's been serious drought for several years there, and people are starting to cull cattle herds. Also dry up along the Red River in the vicinity of Childress there in the southwest corner of Oklahoma. And then the third area I want to highlight is in south central Texas, which includes Austin and San Antonio. The graph on the top right is for Canyon Lake, which is a reservoir in the hill country, which was created in the 1970s, 60s, and 70s, and had never been below about 70% full until this drought, where it's dropped down close to 50% and is still every day setting records for lowest reservoir level on record for that reservoir. An even larger reservoir is Choke Canyon Reservoir, which is south of the long-term drought area, but its watershed covers about half of that long-term drought region, and it too is low. It's low more frequently than Canyon Lake, but again, we're hitting historical levels of drought for long-term supplies. Much of the area relies upon the Edwards Aquifer for water supplies, which is a limestone karst aquifer, very closely tied to surface water levels. So when the reservoirs are low, the aquifers are low too, and water suppliers are starting to implement water use restrictions in that area because supplies are so low. And ultimately, the aquifer levels can't drop too low without threatening endangered species. So it's a very closely managed system. Next slide shows a historical perspective for the state as a whole for precipitation for August through October. We're not done with October yet, but so far what we've got is that blue dot in the lower right, which would be comparable to the driest August to Octobers on record since the drought of the 1950s. Closest analogs would be 1963, 82, and 99. So there hasn't been an analog for this one for 25 years. I put 2011 in parentheses because that drought was at the end of the driest year on record for Texas. So that was much worse than this one and really doesn't serve as a point of comparison. But compared to everything since then, we're less than half of the next driest year in this millennium. Next slide shows that actually the dryness is only fairly recent. This is a plot of accumulated precipitation across the state of Texas, and the blue line is the current year. Up through July, we were doing great. We'd received almost 20 inches of rain statewide, which is 2/3 of or 3/4 of the normal annual total. So, except for those three smaller areas I highlighted, this has been a short-term drought. September and October numbers so far were estimated with those dots. So we're actually, unfortunately, converging to having a normal year, but we're en route of doing that through well above normal precipitation for the first half and well below normal for the second half. And unfortunately, having the first half being wet doesn't help us a whole lot because in the summertime, soil moisture gets depleted fairly rapidly with the high temperatures. And so essentially, the climate system does a reset on available moisture, and we start accumulating it in September and October, which is climatologically the second wettest period of the year for Texas. But it's just not happening right now. And that has a few important impacts I want to touch on. First off, on the next slide, we've got the wildfire occurrences across Texas. And the bar chart shows the daily numbers of wildfire responses by the Texas A&M Forest Service. That's not the total number. This is just the one where the state resources are being called upon. It peaked out with 16 new fires in one day on October 16th. The colors on the bar charts correspond to the region colors on the map on the right, where the red dots are the wildfire occurrences. So you can see it's been active primarily in the eastern part of the state. That's an area which has widespread pine forests with some oak woodlands as well. And of course, pine trees produce a lot of dried pine needles on the ground and so forth. And that's all ready to burn on fairly short notice, as long as we have very dry conditions for several weeks to a couple months. And that's what we've had. And so right now we're dealing with lots of fires. They don't tend to be particularly dangerous unless we have dry conditions with very strong winds. So the most vulnerable times are typically when we had a cold front coming through with strong wind gusts from the north. We had one of those last week, which accounted for part of the peak in those fires. Hopefully we won't have another one before the humidity increases. Next slide shows some of the agricultural implications from the latest Texas A&M AgriWac crop and weather report. I've extracted the highlight information for basically farming operations on the left, ranching on the right. If I haven't highlighted it, it means things are behaving normally or well. Yellow means there are emerging issues, and the pink means there are serious issues already. So as far as agriculture goes, we're harvesting some crops and planting or hoping to emerge winter wheat. And basically, winter wheat needs more moisture at this point, either to get in the ground or to get germinated and get established. Some of the harvests of pecans and cottons have been kind of poor in the southern part of the state. In other areas, it's been okay. In ranching, conditions seem to be a bit worse in general. We have areas that have very poor conditions as far as rangeland goes. Producers are starting to cull herds in some areas. A lot of areas are basically at the alarmed stage because stock tanks, the ponds from which the cattle get their water, are depleting, and they really need some more moisture coming in to make sure cattle can actually survive. And pastures are suffering in many areas as well. So last slide, summary. We've got water restrictions in places. We've got ranching being impacted. We've got lots of fire activity. And for the most part, the farm and ranch impacts are somewhat reversible if we get rain soon, but we'll hear about that at the end of this webinar.
Thank you, John. Very interesting information. I've got one just really quick question for you. You talked about when you're showing the SPI map, and there's a large area of dark red out in far western Texas. You said part of that is poor radar coverage. Could you very quickly explain the connection between how radar influences the SPI?
Okay, yeah, our input data for that particular product is called stage 4 precipitation data, and so that's produced basically primarily relying on radar data from the River Forecast Centers of the National Weather Service, and it's designed for flood warnings, so it's not really designed to capture whether things are dry versus really dry. At the Southern Regional Climate Center, we're developing an alternative product that relies more heavily on gauge-based data, and so that'll help provide better information in that region.
Oh, very interesting. I didn't realize that there was the different stages of data being input, and it'll be interesting to see what the Southern Regional Climate Center comes up with the new development. Anyway, thank you so much, John. I'm going to now pass the mic over to Gary McManus. Gary, I'm going to give you presenter permissions first, and as soon as you have that, just go ahead.
Thank you, Joel. I hope you can see my screen.
Yes, we're seeing it.
Okay, awesome. Like John in Texas, and of course Matt up in Kansas, we're having lots of fun with drought. That slide there, the title slide, that's a picture from northwestern Oklahoma last year during the height of the drought. So it's not the Sahara Desert, unfortunately, it's Oklahoma. So like John said, we do have long-term drought impacts going along with the short-term drought impacts. So when we look back at the drought of what I call is the drought of 2021 to 2024, I guess it's debatable whether the drought actually ended this spring when we had a little help from El Nino. But August 2021, the drought began under that triple dip La Nina. Of course, the next 3 cool seasons we had La Nina conditions. So December 2021 was the first of our 4 flash droughts, what I consider flash droughts. You can see down here in the graph below that rapid intensification we had during December. December 2021, Oklahoma was 10 degrees above normal, and we beat the previous warmest December by 5 degrees. Absolutely unheard of in Oklahoma's climate record. Then we had another flash drought after some relief in June of 2022, another flash drought in July of 2023, and then sort of flirting with drought during the spring and summer of 2024. And then, of course, we have another rapid intensification going on currently over the last 2 to 3 months. Our current drought concerns, all the greatest hits, as I say, lack of soil moisture. Winter wheat crop is starting to suffer with not being able to be planted due to the lack of soil moisture. And of course, that was planted, dusted in basically, not enough moisture to get it to germinate and emerge. Wildfires are becoming a bigger hazard, and reservoir levels reflect that longer-term drought. And one of the things I want to touch on is how long will it last? Some of the anecdotal evidence maybe that we're a little bit under the gun with how long this current drought period could last. So the current drought concerns, as I said, across Oklahoma are high, with drought currently spreading and intensifying. We currently have about 71% of the state in drought conditions, about 86% of the state in drought conditions or abnormally dry conditions. Those yellow areas, in this case, signify areas either coming in or going out of drought. Most of that yellow is areas threatening to go into drought. And you can see the drought monitor classification change over the last 2 months. We do see widespread areas of 2 to 3 intensifications. We do have a little area up in northeast Oklahoma that intensified 4 categories, and that's what we're going to see more of, unfortunately, if we don't get significant rainfall in the next few weeks, as we do see mostly severe to extreme drought, no exceptional drought, that D4 category, but that's on its way, again, like I said, if we don't get some significant precipitation soon. Deficits have continued to grow over the last 30 to 120 days. You can see up in the upper left-hand side, just over the last 30 days, it's really a departure from normal map that you would see with no rainfall. So widespread areas of 2 to 3 inches below normal, and up in far northeast Oklahoma, down in southeast Oklahoma, over 4 inches below normal. But those departures intensify as we go through 60 days, where they increase from 4 to 6 and then 7 to 8 inches in parts of the state, and even more than that, up in 90 days, a departure from normal map from the Oklahoma Mesonet. We see areas, lots of areas from 6 to 8 inches below normal, and then as much as 10 inches below normal up in northeast Oklahoma. The same thing for the last 120 days. One thing you'll notice, though, is that the high plains and far northwest Oklahoma, still the best areas of the state for rainfall, at least as opposed to normal. Those are the areas that have gotten, I'm not going to say consistent, but they've gotten lots of rainfall, sometimes in very short periods of time. So maybe these maps are a little bit off for that regard, but a little bit deceiving. But at least they've gotten some heavier rainfall over that time frame. So one of our hits is the lack of soil moisture. You can see from the upper left map, this is the one-day average 4% plant available water. So a theoretical maximum calculated each one of these mesonet sites. What's the percentage of that maximum, that theoretical maximum available right now? You can see lots of single digits, lots of very low teens. Very few areas of the state are well off for that 4-inch, the top 4 inches of the soil, that soil moisture. Same thing for the top 32 inches. Lots of single digits, lots of mid-teens, some 20s in there. Very few areas, once again, showing good soil moisture amount available for those plants to use as they are still trying to grow to some degree, especially that winter wheat crop. And then, of course, you can see the USDA numbers, the topsoil moisture percent short to very short, now up to 81% for Oklahoma. That's up 4% from last week. And, just a few months ago, we were setting in the 30s and 40s for that percentage. So we have increased quite rapidly as we've gone through a very dry and at times very hot summer across the state of Oklahoma. We see delayed winter wheat planting as one of our impacts. You can see from the upper left map once again that the primary areas those dark green areas, the major winter wheat crop areas in Oklahoma and parts of Kansas, parts of Texas. Most of that area is in the drought area, that red hatched area. So that's a significant portion of the winter wheat crop trying to be planted in drought conditions. So a lot of that's been invested in, and you can see the winter wheat progress from the USDA, 55% planted as of now, and that's 16% below normal. We see a similar type of a map for the amount that has emerged. So winter wheat planting and the progress currently in Oklahoma is behind schedule, and it's not doing well, obviously. Wildfires, we are seeing more and more wildfires across the state of Oklahoma. One of the things we look at, even though we're still sort of in the transition phase between warm season and cool season here in Oklahoma, we have had a widespread freeze so far, so we are transitioning to the cool season, at least as far as the vegetation goes. But when we look at this 16-inch plant available soil moisture, that's one of the things that the fire researchers at Oklahoma State University have come up with to indicate the danger for large wildfires. So, once we transition to the cool season, we'll look to more fire weather to be the day-to-day fire weather conditions to be our main driver of wildfire danger, especially those large wildfires. But while we're still sort of in the transition phase, this still does hold some value. And you can see we are across most of the state seeing extreme large wildfire potential during this time frame. And as you look at the relative greenness map for the state of Oklahoma, of course, you can see the winter wheat belt from southwestern up through north central Oklahoma. But even outside of that area, lots of areas that are seeing the lack of green vegetation, especially up there in northeast Oklahoma. Very unusual to see up in northeastern Oklahoma those type of relative greenness values, the lack of green vegetation for this time of year. I want you to notice also up in the Oklahoma Panhandle and the High Plains, we do see those values starting to drop. Part of that is due to the freeze. They had a hard freeze up in that part of the state, and part of that is due to just a general browning as they've lost sunlight for this time of year. Wanted to talk about that area. That's why I brought that up, the wildfire season, keeping receipts from the summer precipitation. You can see the precipitation values for June through July. And up in the High Plains, that's actually some of the wettest parts of Oklahoma during that time frame, rivaling even down here in the southeastern Oklahoma. So we had a lot of warm season precipitation up in that part of the state. And you can see from this relative greenness map at the beginning of September, lots of green vegetation up in that region as well. So that's a lot of vegetative growth up in that part of the state that is just waiting for the dormant season. And then up in that part of the state, as I showed you in the previous map, they've reached that dormant stage for the vegetation up there. So as we transition to the cool season, dormant season wildfires, that's one of the things that we're particularly worried about. In fact, one of Oklahoma's Forestry Service wildfire people, he termed it unnerving, which is certainly not something you want to hear from an expert in that field. So, but he really said, across most of the state of Oklahoma, it's not looking good for wildfires as we go into the dormant season. And as we look at the longer term drought levels, across the state. We also see those reservoir levels continuing to drop. Down across southwest Oklahoma, Lake Lugard-Altus, 18 feet below normal. Tom Steed, 9 feet below normal. Lugard-Altus is an important reservoir for cotton irrigation. This is the third year in a row that it has not been able to be used for cotton irrigation. But all across the state, you see those values starting to drop. 10 feet below normal at Skiatook up in northeast Oklahoma. Worcester in the far east central Oklahoma, 5 below. And the reservoirs around central Oklahoma, Lake Hefner, which is Oklahoma City's main reservoir for drinking water, is 7 foot below normal. And so today they've announced they are releasing water from Lake Kenton up here in northwest Oklahoma, which will drop Kenton down several feet, but it will help Hefner. So, when we have these long-term drought impacts like these reservoir levels, it's not just local. It can impact the states, or it can impact the reservoirs around the surrounding regions as well, as those reservoirs are used to bolster those larger cities of water supply. Just one thing I wanted to end on: how long will it last? We've seen a propensity for these dry spells to start in the fall and last through winter into early spring. Especially during La Nina cool seasons, and this one's already had a big start. So you see, just, again, anecdotally, February of 2018, we had parts of the state going up to 150 days without a quarter-inch of rainfall in a single day. Just last year, we had out in the Panhandle close to 200 days, consecutive days without a quarter-inch of rainfall. And already this fall, we're up to 30 days over much of the state, and in some parts of the state, we're up to 70 days. So if this does occur like it has in the past, and then we've seen this over the last 6-7 years, that would not be good to give it this much of a head start for that dry spell to continue. And that's my information for today, and there you can see my contact info, and I will now turn it back over to Joel.
Thanks, Gary. It's not looking great. Just a quick question. Early on in your presentation, you showed a time series of U.S. drought monitor conditions, and it was the time series was showing the percent of area in Oklahoma that was within drought for the last few years. Yeah, this is the one. And for the last 4 droughts that you're showing, they all seem to come on fairly rapidly. And you mentioned you used the word flash droughts here. Is that pretty common for Oklahoma, for droughts to onset rapidly, or is this a new pattern that you're seeing?
Well, again, we go back to, is this actually a 4-year drought, or is it, a series of smaller droughts? I consider it a 4-year drought. Okay. I haven't seen anything in the recent past. We did have that same thing in the drought from 2010 to 15, where it was made up of smaller droughts, but not flash droughts. So the distinct levels of drought, those intensifications coming on in short periods of time, do seem a little bit unusual, at least from what I've seen in the drought monitor era. But, when we're dealing with a drought like this, we haven't really seen many 3 to 4 year droughts outside of that drought from 2010 to 15. So maybe it's a little bit hard to say with a small sample size.
Sure. Well, thanks for explaining that for us, Gary, and thanks for your talk. I'm now going to pass over to Matt up in Kansas. Matt, I'm going to give you the presenter permissions now. Once you get that, once you're sharing your screen, just go ahead and get started.
All righty.
We can see it.
Okay.
Go ahead.
Can you hear me as well?
Yes, sir.
Excellent. Thank you, Joel. Good afternoon, ladies and gentlemen. I'm Matthew Siddle, Assistant State Climatologist at Kansas State University, and I am glad to be here today to share the current situation of drought in the state of Kansas. I thought we would start by taking a look at the current U.S. Drought Monitor. This is the most recent issue, which was last Thursday. And you can see nearly the entire state of Kansas has some shading of drought conditions. Really, there are just a couple of areas down in southwest Kansas that are drought-free at the moment. Most of eastern Kansas, however, is not looking as good, unfortunately, with quite a bit of D2 and even a little bit of D3 that you can see down there in the far southeast. If we go by the numbers, we can see that, hang on there, my slide is not advancing. Let's see, there we go. Sorry about that. Currently, only 3% of Kansas is drought-free. 3 months ago, we were at 42% of the state being drought-free. So this is definitely a worsening of conditions. We've got 16% of the state currently in D2 or worse conditions. That's the highest amount we've had in the state since late May. For those who are familiar with the Drought Severity and Coverage Index, it's a composite index. It can range from 0 if the entire state were drought-free to 500 if the entire state were in D4. Right now, that index for Kansas stands at 179, which is the highest it has been since late April. And it would only take 3 additional points on that index to be the worst drought conditions in 2024. And that's very likely to see that number rise with the next issuance of the drought map on Thursday. And finally, we added D3 back on October 8th. We had a nice 17-week run where we had no D3 in the state. But unfortunately, given how dry it has been, it was necessary to return Southeast Kansas into D3. If we take a look at the 30-day precipitation departures across the state, you can see nearly the entirety of the state is below normal for precipitation. Southeast Kansas has the largest deficits. That's also a function of the fact that Southeast Kansas, climatologically speaking, has more precipitation on average in October versus farther west in Kansas. However, there's only one exception that you can see, and that is up in north central Kansas around the Phillipsburg area, which we'll talk a little bit more about here in just a couple moments. This is the accumulated precipitation departure from 1991 through 2020 against, the 1991 to 2020 normals. So if we use April 1st as an arbitrary start to the growing season, since that time, you can see the majority of the state of Kansas is below normal for precipitation. We have a few areas that are as much as 10 inches or more below normal in far southern Kansas, for example, in Sumner County, south of Wichita, and in Montgomery County, where Coffeyville and Independence are located. There are a few places that are above normal. The southwest Kansas, around the Dodge City area, had a lot of precipitation in the spring. And there's also a couple of smaller areas in northeast Kansas, for example, here in the Manhattan area. We are currently 2 inches above normal for the year. However, had you gone back a few months, we were as much as 7 to 8 inches above normal. So a lot of that surplus that we had initially, we have lost here, given the dryness that we've had recently. We were very excited in the state to get some rainfall yesterday and the day before. This is a depiction of the 7-day precipitation totals from our Kansas Mesonet website. One number should stand out in particular, right there in Phillips County. We have a Mesonet tower near the town of Phillipsburg that recorded 2.84 inches of rainfall, which was great news. Unfortunately, those totals were not seen in other parts of the state. You do not see any numbers plotted here that are any higher than, I believe, 7,800 is the next highest amount, which is down in Reno County near Hutchinson. So Southeast Kansas in particular missed out on this event. No precipitation recorded there, and just to the northwest of that, a lot of totals under 1/10 of an inch. As we were just referring to, you can see from Phillips County, there was a very narrow band of heavy precipitation that occurred there yesterday. There was also some hail contamination, we feel like, in this particular depiction, because there was hail as large as golf balls reported in Phillips County. But you can see outside of that area, really no other significant precipitation, which is really unfortunate because at this time last week, we were really excited about the potential of getting heavy precipitation in the western half of Kansas. And as many of you, I'm sure, have heard, those heavy totals were mostly in New Mexico, especially in the Roswell area, where they had the record 1-day precipitation amount of well over 5 inches. Unfortunately, we missed out on that. But if we look at how long it's been since 1/4 of an inch of precipitation fell across our Kansas Mesonet network, you'll note there are a few lucky places in northern and west central Kansas where it's only been 1 day, and they got over 1/4 of an inch of rain yesterday. For parts of southeast Kansas and southwest Kansas, it has now been a month since there has been that much moisture. And in fact, yes, some of the locations in southeast Kansas are precipitation free so far in October, because again, they did miss out on that most recent precipitation event. One area that has been a concern for a while is Cheney Lake, which is one of the main sources of water for the city of Wichita. Currently, that reservoir is only 54% full. That's dropped 3% since the start of October and is now running over 8.6 feet below normal. And that is actually the lowest level that Cheney Lake has been at since 1972. As a result, the city of Wichita is in a stage 2 drought plan, and the town of Wichita nearly 10 inches below normal for 2024. One interesting story that I found concerning this drought was because the water levels have been so low, there was a gentleman who was doing some metal detecting and happened to find a class ring that someone lost 48 years ago in the now visible areas of Cheney Lake from the reduction of the water, and he was able to return that ring. So clearly this is a historical event for Cheney Lake, that it's been that dry. Another thing I wanted to point out is if we take a look at average temperatures, just for the month of October, you'll note nearly the entire state of Kansas is above normal. And there is a tendency as you go from east to west to see increasing departures. One of the warmest places in the state is the town of Goodland out in Sherman County, where the average temperature right now for the first 21 days of October is 60.8 degrees. It's 7 degrees above normal. But more interestingly, if they can stay above 60.5 degrees through the end of the month, this will be the warmest October on record for the city of Goodland. And while other parts of the state are not likely to have their warmest October, a top 5 warmest October is very possible for a number of locations in the western half of Kansas. We've still got 10 days to go, and we'll have to keep an eye on those records and see if they actually end up being broken this year. But it's very unusual that it's been not only dry, but also much above normal. And I wanted to summarize some of the specifics regarding this pattern here for the month of October based on our Kansas Mesonet data. I want to take a look at average temperature as well as 2-inch soil temperature, the average diurnal temperature range, and also our it should be total evaporation, excuse me, evapotranspiration, not an average of a total. The numbers here in this column, this is what we would normally expect for the first 21 days of October. A statewide average temperature of 58 degrees, which is also very close to the 2-inch soil temperature for the date, October 21st specifically. And then in an average day in the first 21 days of October, we expect a diurnal temperature range of about 27 degrees, and total evapotranspiration for the first 21 days of October runs about 2.46 inches. Well, how do these numbers look with respect to this year? Well, so far we are running 4.6 degrees above normal for our average statewide temperature. Soil temperatures are running also 4.6 degrees above normal. One of the more interesting things that I found here is that because it has been so dry here and the air has been dry, we've had lower dew points, and our average diurnal temperature range this month has been 33 degrees. So we've had some reasonably close to normal mornings, at least earlier in the month, and then we warm up quite a bit during the afternoons. Also, because of that dry air, our total evapotranspiration for the month of October so far across the state is at 3.21, so it's 0.75 of an inch above normal. So not only are we seeing a lack of precipitation and above normal temperatures, we're also seeing increased evaporation demands because of the drier air. So unfortunately, it has been dry and may very well continue to be dry. That topic I will reserve for our next speaker. I'd like to thank you for your interest. I'll take any questions. I also would invite you to take a look at our Kansas Mesonet webpage. We're also on Facebook and on X. And we also publish a weekly climate report. If you're interested in receiving that straight to your inbox, drop me a line at msiddle@ksu.edu. Thank you.
Thank you, Matt. Great information. Just a quick question on the last point you made about the averages and also this large diurnal range. So with lower humidities and a large diurnal range, has there been a frost in western Kansas yet?
We actually did have a first freeze across much of the state. I would have to go look at the exact date. I've already forgotten. It's embarrassing when you have a whole state of data to pay attention to.
Sure.
But yeah, we have had most of the state. We had a couple of 18-degree temperatures, surprisingly. We had one up in north central Kansas, as well as down in far southwestern Kansas at our Clark County site. The only places that did not have a freeze were southeastern Kansas, but most of the places that had a freeze, it was not a killing freeze.
Okay.
Had a couple of hours, upper 20s. So theoretically, their growing season is still continuing for much of the state. We have not seen another freeze since, and depending upon what our next speaker says, it may be a while yet before we have our second freeze in the state.
Great. Thanks for that, Matt. Love the information. I'm going to pass now the presenter permissions over to you, Adam. It'll take me just a second to get to that. Adam, you should see a little pop-up saying that you can share your screen, and when you get that, go ahead.
I do. Now I want to share. Yes. All right. Can you confirm you see my screen quickly?
Yes, it's not in presenter mode yet, but we are seeing it.
All right. Excellent.
All right, looks good.
All right. Good afternoon, everyone. My name is Adam Hartman, forecaster at the Climate Prediction Center. I'll be presenting today on the monthly and seasonal outlooks for temperature, precipitation, and drought. I want to give a quick shout out to our forecasters that released these forecasts back on Thursday, October 17th. Our chief of the operational prediction branch, John Gottschalk, produced our seasonal temperature precipitation outlooks. The climate testbed director at the Climate Prediction Center, Matthew Rosenkrantz, produced the monthly outlooks, and our drought lead, Brad Pugh, produced our seasonal drought outlook for the November to January period. So before diving into the outlooks themselves, kind of general broad overview of kind of what goes into these outlooks. So we look at various forecasting tools, such as dynamical and statistical model guidance, constructed analogs, sea surface temperature patterns, and things of that nature. But some of the major things we look at are modes of climate variability. And one of the most popular and arguably most influential with respect to circulation patterns globally is the El Nino Southern Oscillation, or ENSO. So currently, ENSO neutral conditions are present in the Pacific Ocean, which means that sea surface temperatures in the tropical Pacific are near normal within the plus or minus 0.5 degrees Celsius anomaly range. But right now we're actually on the colder side of that range. So sea surface temperatures presently are actually near and below normal in that region. Our ENSO diagnostic discussion that was recently released indicated that La Nina, or cooler than average SSTs in the tropical Pacific, is favored to emerge by the end of November with at least a 60% chance. And those conditions are likely to persist through much of the winter season and even potentially into early spring. Now, what does that mean for circulation patterns over North America? If you look at this figure over to the right, typically La Nina conditions result in a northward shifted or northward displaced storm track across the North American continent. And that typically leads to colder and wetter conditions here across the northern tier of the continental US. And conversely, warmer and drier conditions here along the southern tier of the US. Now, there are some nuances to this predicted La Nina event. One is that it is favored to be weak and of short duration. And typically during weak La Ninas, impacts are less likely to, I guess the impacts we typically see from La Nina are less likely to occur, but we still expect it to provide a meaningful influence on these outlooks. Also, with the weak La Nina, this kind of opens the door for other modes of climate variability. They could be tropical in nature, such as the Madden-Julian Oscillation, or MJO, or even the kind of mid-latitude to polar latitude type of teleconnection, such as the Arctic Oscillation or North American Oscillation. Those climate modes may provide some increased subseasonal variability due to the weak La Nina. So what does that mean? It means that there may become some shorter term shifts in weather patterns that, for example, here over the southern tier where you see warmer and drier, you might see colder and wetter conditions. So don't rule out some of those shorter term shifts in weather patterns. So looking first at the November outlooks, here on the left is the monthly temperature outlook, here on the right is the monthly precipitation outlook. Here where we see these kind of deeper red colors, those are higher forecast probabilities for above normal temperatures here on the left, which basically means we have greater confidence that by the end of the month, the collection of all the various weather events throughout that month will result in above normal temperatures for these areas. I apologize, there's a dog barking in the background. Here on the right, it's a similar case for precipitation. These kind of darker brown colors here represent increased chances for below normal precipitation. Here, whether you see the white kind of as we head towards the Central Plains region, this lack of color, that means basically there's no real chance for probability to swing one way or the other. There's equal chances of above, below, and near normal for temperature and precipitation, respectively, from left to right. So that basically means we're not really sure the models aren't really sure what's going to happen by the end of November. So looking now ahead to the season as a whole, the November to January period, we're not really expecting much to change. We're still expecting increased probabilities of above normal temperatures and below normal precipitation for much of the Southern Plains region. Now, I did mention La Nina is expected to develop by the end of November. So, but we don't expect kind of that atmospheric response and to see that footprint really take hold until really starting around probably the December to January period. So again, although La Nina is weak, we do still expect it to kind of impart its footprint on this forecast, and we do see that here with that these above normal temperature probabilities and below normal precipitation probabilities, in addition to the trends that we're seeing in these regions as well. This region there during this time of year is trending warmer and drier than average. Now taking a look at the seasonal drought outlook, what does this all mean? So in the previous presentations, you saw that antecedent dryness over several months across much of the southern and central plains. That antecedent dryness, coupled with these above average temperatures and below normal precipitation that are favored, indicate that widespread drought persistence is likely across the central and southern plains, with the possibility of development across much of the southern plains. So looking at the graphic here on the left-hand side of your screen, these brown areas indicate areas that are currently in drought, where drought is expected to persist or even potentially worsen, particularly across the southern plains. And these areas of drought are based on the U.S. Drought Monitor. We use those as initial conditions for our drought outlooks. Here in the yellow is where drought is currently not depicted in the U.S. Drought Monitor, but where it is expected to develop given those warm and dry conditions that are favored. Now here in the Central Plains, it gets a little more dicey. So as we head towards especially the end of the season, trends kind of offset La Nina signals a little bit. So there's a little bit more, I guess, uncertainty in the forecast here with respect to temperatures and precipitation, mostly precipitation. Now, I wanted you to take this kind of depiction with a grain of salt. We don't expect drought to look exactly like this by the end of January. What we're saying here is that during the season, that interseasonal variability, that subseasonal variability that I kind of alluded to earlier, you may have some areas that improve or even get removed in drought, or you may have some drought expansion, but ultimately we expect drought coverage to remain the same overall for these areas here in the Central Plains. Now, because we released the winter outlook recently in conjunction with our normal monthly release of our seasonal outlooks, I wanted to kind of look forward even ahead of the upcoming season a little bit, just to say basically that we are expecting conditions not to change very much, particularly for the Southern Plains south of the Red River predominantly. But you do see these increased equal chances popping in here into the Central Plains and Middle Mississippi Valley even. And that's primarily due to some offsetting signals related to the trends as we head deeper into the winter months. So what does this all mean? So what I want you to take away here is that La Nina is likely to develop by the end of November and last through most of the winter season. potentially even into early spring, but it is favored to be weak. Much of the southern plains is forecast to be warmer and drier than normal through the end of January, with the potential for these conditions to also last through February. Given the weak La Nina, other modes of climate variability may bring brief periods of cooler and wetter conditions, maybe some reprieve, but overall seasonal conditions are favored to resemble that La Nina footprint with those warmer and drier conditions as a whole for the season. And the biggest takeaway of all, the antecedent dryness, the warm and dry temperature and precipitation outlooks respectively, favor widespread drought persistence and development across the southern plains.
Thank you, Adam. Just a quick reminder to those who are watching this webinar, we have about 10 minutes left of the scheduled time. If you would like to ask a question, go ahead and type it into the question box, and I can direct that to any of the presenters who spoke to us today. And while I'm waiting for some other questions to come in, Adam, I have a question specifically for you about your talk. So you mentioned a few times that with this weak La Nina, we have these other modes of climate variability that will impact our weather throughout the season. So we might see like a short period up and down in precipitation or temperature. You mentioned specifically a few like the Arctic Oscillation and the Madden-Julian Oscillation. One of the reasons that we really like La Nina is that it gives us a long stretch in predictability. It usually begins and sticks around for a full season. Can you comment on the predictability and especially the timeliness of the predictability of some of these other climate drivers that you've mentioned?
Sure. So INSO is definitely a low frequency predictive state. So happening over the course of, I would argue, several months, let's say. So that's your very low frequency state. Some of these other drivers like the Madden-Julian Oscillation, that's on the order of weeks to maybe even like probably I would say 30 to 60 days. And that's that's the outgoing long wave radiation or the precipitation pattern. You have kind of a wave that propagates around the tropical, around the equator, essentially, bringing kind of chances for above normal precipitation to some locations and below normal precipitation to other locations, that can ultimately influence the mid latitudes as well. And then some of your other modes of variability happen on even shorter time scales, and that's the NAO and potentially even the AO. Although those modes of variability, and those are mid-latitude modes of variability, excuse me, and those modes of variability can probably on the order of weeks to maybe even a month with some of your longer duration events. The AO is a particularly important one. A negative AO typically means there is the potential for like cold air outbreaks across the northern hemisphere, whereas a positive AO means kind of the polar jet is more contracted to the polar latitudes. So you end up with warmer and drier conditions, for example, across typically across the U.S. So all these kind of like shorter term can all play in that variability that can bring these shorter term events to fruition, offsetting the low frequency El Nino background state of warm and dry, for example. Does that make sense?
It does. Thanks for explaining that, Adam. Adam, there's another question for you. It's from John Nielsen-Gammon, who was our first presenter. John, go ahead and unmute yourself and ask your question.
Yeah, thanks. Actually, a couple of questions I think are quick. The first one sort of bears on the slide you have up here.
Okay.
It seems in Texas that we get our coldest cold air outbreaks during neutral or weak La Nina conditions, and I've explained that as being, well, there's more colder air up north that's available to come down. I wondered whether you'd seen the same sort of thing. And the second question is there anything important about the La Nina threshold that is affecting the weather? Or is it just sort of a continuous variation of influence, like a tropical storm is just weaker than a hurricane, but there's nothing terribly special about crossing the hurricane threshold?
So to your first question, given the wetter, colder northern tier, if you will, of North America, that typically does lead to increased snowpack, which basically means that this air mass becomes a lot colder and allows the potential for more cold air intrusion into the central portions of the U.S. during the season. So yeah, that potential definitely can exist. That being said, as a whole, that overall storm track still remains kind of, I don't want to say this, compressed, shifted northward on average. So these cold air events will be probably few and far between. They do happen, but on average, we expect the times between those cold air outbreaks to offset that, and ultimately the season as a whole to be warm. And that is typically what we see with La Nina. What was your second question again? My apologies.
It was about whether the La Nina threshold was significant for impacts.
Yes. Basically, with the weaker La Nina, it does allow for a little bit more dominance potentially of those other climate modes, and basically lead to more subseasonal variability. And that kind of ties in with, if we go to like the seasonal outlook, for example, during a typical La Nina year, you actually would probably see higher probabilities for above normal and below normal precipitation across these southern areas, much of the southern tier of the U.S. for that matter. But we actually see these kind of weaker probabilities here for above normal temperatures, and even equal chances, no signal at all here in the central plains, even getting into portions of the southern plains. And that's likely due to kind of maybe those offsetting signals, with the potential for these other modes of variability to kind of add enough subseasonal variance that you may see near normal conditions, potentially.
Thanks, Adam, and thanks for those questions, Gary. John. So the next question is for Gary. We have just a few minutes left, and I've got two last questions that I'm going to ask. So this is for Gary. It's from Casey at Oklahoma Farm Report. Hi, Casey. How would you compare the beginning of the drought season now to the ones that we've seen in the past? Is it better or worse? And can you comment about long-term drought or the long-term outlook? But I guess I added some words there. Better or worse long-term outlook?
I guess what I would be looking at is this is our fourth iteration of drought in the last 3 years. So I think we have enough stored memory of the previous droughts where this one could be pretty nasty if it continues. And with what Adam presented, it does give us pause, especially across the southern half of Oklahoma, to worry about that drier than normal and also warmer than normal signal. So, it's certainly right now not as bad as we saw in, even 2022 or 2023. But those droughts, they will have an impact on our current drought situation. Just like I showed with the reservoir levels, all those things compound and accumulate. So I think the current drought situation has a pretty good head start on those previous two droughts. Maybe not the third one, the flash drought, but this one's a little bit more supercharged due to that previous dryness, in my opinion.
Thanks, Gary. One last question. I think this might go to John, but I think anybody could pick it up. And I'm going to probably reword it a little bit in a way that makes sense to me. I'm sorry for whoever asked the question if I don't ask this right. Is there a rough idea of where the line between, quote, a real winter and a weak winter occurs? Like, how do you know if it's been a good winter or a bad winter? The question continues with, would such a line follow a 20-inch or 30-inch frost line, for example? And for context, the question asker lives in Amarillo, Texas. Anybody want to pick that up?
I'll just say it depends, because the risk of extreme cold increases as you go north, but the farther north you go, the more used you are of cold conditions that would be unusual and very detrimental farther south. In the state of Texas, the difference between normal wintertime minimum temperatures in South Texas and North Texas is about 30 degrees. So there's no hard and fast rule. We look at things like hard freezes, 24 degrees, 20 degrees, and each of those are important, but I'm not aware of any universal thresholds.
I would
Thanks,
also
John.
argue that the timing of events throughout a given season, you can have a near normal season for precipitation, temperatures, et cetera, but the timing of those events and the duration of those events have impact on maybe how drought would develop or kind of impacts you're seeing as well.
Thanks for adding that context, Adam. I'm going to wrap us up there. Thank you again to all of our presenters, John, Gary, Matt, and Adam. Fantastic information, and thank you so much for taking your time and sharing your expertise with us. And thank all of you for attending today's webinar and for your participation with the questions. Just as a reminder, this webinar will be posted online at drought.gov/webinars within the next few days, and when I get around to it, and I will send around an email when the recording is available. Thanks again to those who helped put this webinar together. And I'm Joel Lisenby from NIDIS and Drought.gov. Thank you all for joining us. That concludes today's webinar.